Yeah, you are welcome once again. This is Patrick Kamala, a tutor and educator here at State College Pulukwani. Today we are doing paper 1, that is physics for Limpopo trial 2024. And believe you me, if you can understand this question paper without framework, you're gonna be sorted. You're gonna be sorted for the November exam. Why not? Let us start. Now this is Limpopo and question 1.1. Let's check it out now. Question 1.1. They said that when two forces touch each other, the component of contact force parallel to the surfaces is called. Now they're saying when two surfaces touch each other, the component of the contact force, which is parallel, that touches the surface, is called. Is it applied force, normal force, gravitational force, or frictional force? Now the answer is frictional force. The answer here is frictional force because it's a contact force between two surfaces. Okay, because it's what? It's a contact force between two surfaces and it acts parallel. Okay, 1.2. They said that a person is transported to a mythical planet Mango, which is 8 times as massive as Earth and has twice the diameter. The person's weight on the planet Mango compared to his weight on the Earth would be, I repeat, a person is transported to the mythical planet Mango, which is 8 times as massive as the Earth. Mean that the mass of Mango, okay, let me call it M prime, the mass of Mango is the same as 8 times the mass of the Earth, okay? And then they say here, and has twice the diameter, meaning the diameter of Mango is twice that of the Earth, meaning that also likewise, even radius of the Mango also gonna be twice radius of the Earth, okay? So the question says here that the person's weight on the planet Mango compared to his weight on Earth. Okay, so how do we find the weight? How do we find the weight, guys? We know that weight is given by mg. Okay, so the weight of that man on planet Earth equals the mass of the man times gravity. That's the weight on Earth. Ne? Now, what's important here is to find the gravity on Mango, our prime. So gravity on Earth, this small g which you see is given by g equals to g, then mass of the Earth, okay, divided by radius of the Earth. Now this is on the surface of the Earth, ne? Squared, okay. Let us find out about Mango. So likewise, the g on planet Mango is given by the universal gravitational constant g, then times mass of the Mango, okay, divided by radius of the planet Mango. So, but we saw in our information here that our mass of Mango is 8 times the mass of planet Earth, okay? Then divided by about radius is 2 times radius of the Earth. So now if you check what I have here, don't forget it must be squared, okay? Must be squared here. So it gives me, now this 8, I can write it first here. I can say this is G, mass of the Earth, okay? Divided by, now this 2 squared, it gives me 4, okay? Then I write radius of the Earth. Don't forget must be squared, okay? Must be squared. Now if you check this one here, which I'm gonna put in red, if you check what I have here, this part here, which is in red, is the same as what you see here. Okay, meaning that my gravity at Mango will be the same as 4 over 8, which is 2, times gravity of the Earth. So therefore, the weight on planet Mango for that man, okay, it's going to be the mass of the man, which is constant, times this 2g, okay, times 2g, so it's going to be 2 mg. So being 2 mg, it means that our answer is going to be 2 times larger. So the answer is what? It's going to be 2 times larger, because this here the first time it was just mg on Earth, now it is 2 mg, so it is 2 times larger than the other one. Let's proceed. Next question here. Next question here. What does it say? Question 1.3. 1.3 says here that The acceleration of free fall is determined by measuring the times t1 and times t2 taken for a still ball to fall from rest and pass points x and y. The distance between x and y is h, as shown in the diagram below. It's h here. Rest position. Now note here that our v initial here, the v initial is 0. Then we don't know the v here at point t1 and at point t2, but we know the change in height. Okay. All right. Then they say here, which one of the following is the correct expression used to calculate the acceleration due to gravity? I repeat, the acceleration, okay, you're looking for this acceleration g over the free fall is given by determined by measuring the times t1 and times t2 taken for a still ball to fall from rest, that means v initial is 0, and the pass points x and y. The distance between x and y is h, as shown in the diagram below. Okay, so what I'm going to do to get my h here, I'm going to find the distance from t0 to t1. From t0 to t1, this distance here, have it together, and then later I find the distance now, which I'm going to put in red. Okay, that means the distance from t0 again, okay, up to is t2. So once I find these two distances, then that will give my h, because h equals to red minus blue. Okay, in other words, my h, okay, my h in this case equals to what? Equals the distance, that's the change in y with respect to time t2. Let me say y2 here, minus change in y with respect to time t1, we call it y1 here. Okay, but what do we know, guys? How do you find the change in y when you have initial velocity and you have the time taken? So we know that change in y, delta y, equals to v initial times change in time, okay, plus a half a change in time squared. Okay, so now talking about this first one in blue, we're going to have our change in y, okay, that's change in y1 equals, now the v initial is 0, no? So now make everything here 0, then plus a half, okay, looking for this gravity g, now t1 squared, okay, so mean that this is my equation 1, okay, then likewise change in y2 is going to be change in y2 equals to 0 again, because v initial is 0, then plus also what, plus a half g, then time 2 squared. Okay, now if you check what I told, that is h equals to change in y2 down in red minus change in y1, which is in blue. I can say therefore my h, okay, I can say my h equals to, that's going to be equation 1, it's going to be equation 2, okay, equation 2 minus equation 1 minus what, minus equation 1. Okay, so equation 2, I have a half, that is a half what, a half g t2 squared, okay, then minus 1, that's going to be a half g t1 squared. Okay, so you see the common factor here is a half g. Because I'm looking for the acceleration g, I can say that my h, okay, h equals to g, open brackets, okay, t2 squared minus t1 squared divided by what? By 2. Divided by 2. So from here, because I'm looking for the gravity g, I multiply 2 by h, it's going to be 2h. So 2h equals to g, okay, open brackets, c, t2 squared minus t1 squared, okay. So I divide both sides, ne? I divide by this bracket here, which is t2 squared minus t1 squared, okay. So my gravity g, therefore, is going to be this answer here. Let's check if we have it in the multiple choice alternatives, okay. So what's our answer there? Let's check it out, guys, here. So the answer here happens to be this D. The answer is D. Hope we are together. The answer is D, because we check D, that's what we have here. Okay, next question, that is 1.4 from Limpopo 2024. They said that the sketch graph below represents the relation between momentum P and the time T for a body traveling in a straight line. Okay, so now in this case, what are we supposed to do? So what we have here on the y-axis, guys, we have momentum. But what is momentum? That is mass times velocity, which means that I have got here mass multiplied by velocity. This is change in time. Okay, so the question says that the sketch graph below represents the relation between momentum and the time t for the body traveling in a straight line. Okay, there's no jigga. So they say, which one of the following conclusions based on the graph is true about the net force acting on a body? So how do we find net force? Now F net, F net acting on a body, F net, we know equals to what? Equals to change in momentum, okay, divided by change in time, okay. And in this case, actually, I can say this is mass, okay, then V final minus what? V initial divided by what? By change in time, actually, which gives me my F net, okay, equals to MA, okay. So what we have here, so now if I look at here, because this is MV, I can have I can have this value here, I can have it here, I can have it here, okay. And if you check what's happening here, they said that the net force, we're looking for F net, the net force is exactly 0, uniformly increases, uniformly decreases, remains constant. So let's find out here. Now if you check here, because change in the velocity over change, because change in the, if I take this point here, and this point here, okay, I can say that this point here it's an initial point, né? It's gonna be, it can give us, if you keep mass constant, né? It will give us our V initial, okay. What about here? It will give us our V final. Then we can get the corresponding change in time, okay, change in time here. So mean that this value here, if I find the gradient, I'm gonna get acceleration altogether, and that acceleration is gonna be a constant. So in other words, because of that constant acceleration, F net will be constant as well. So it means in this case, my answer is going to be D. It's going to remain constant. It's not increasing, it's not decreasing, and it's not zero. Next question here. They said that a block X of mass 3 kg is accelerated from rest by a force of 5 newtons for 2 seconds. An identical block Y of mass m is accelerated from rest by a force of 5 newtons for 4 seconds. Which one of the following ratios, EK final for X to EK final for Y, is correct? Want to find out the ratio between EK what? EK final for block X compared to the EK final for block what? For block Y. Okay, so how do you find EK final? It's given by a half what? By a half m V final squared. Okay, for X then here I have what? Half m V final squared. This now for Y. Okay, this is for X here. Okay, so now here they gave us the mass. Mass is the same. We have the differences in the force. The force is the same. Difference is in the time. Okay. So how do we find our velocity? How do we find the velocity? What should we use here? How do we find the velocity here? And what can we use? So in this case, we can say that yes, we said that we know that F net equals to MA, right? F net equals to what? F net equals to MA, given by what? Mass times what? V final minus V initial divided by change in time. Okay, divided by change in time. So in this case, what do we know? If you look at this first one here, we're going to have the mass. We know it is 3 kilograms. Now we don't know the V final, right? Okay, but V initial is what? V initial is 0 because they said from rest. Okay, so the force here, which is 5, okay, so this is 5, equals to 3 times V final, okay, for x, then minus 0, divided by changing time. They said for 2 seconds, so 2 times 5, you get what? You get 10, then divided by 3, equals to V final for x. So in the same way, this side here, remember the force is the same, né? It is still 5, but the time is 4 seconds. It's going to be now 5 again. F net equals going to be 5 equals to the mass is the same, né? Which is 33. Difference is the final for y minus 0 because it's from rest as well. Divided by, they say the 4 seconds by 4. So what is 4 times 5? It's going to be 20 equals to 3 equals to 3v final squared, né? I'm not squared, sorry. So divided by 3. So difference is in the v final, né? This is for y. So when I come here, because the mass is the same, I can cancel this mass like this. I can cancel the halves as well. I can cancel this half with this one here. So my challenge is in the vf squared and the v final squared. Okay, so here to get my ratio, I'm gonna say for x it is 10 over 3. Okay, that is 10 over 3. Don't forget it's squared. Okay, what about for y? It is 20 over 3. Okay, 20 over 3 also squared. Okay, so what is 10 squared? 10 squared is 100. Okay, what about 3 squared? That's going to be 9. What about here? This is 400. Okay, this is 9 here. So multiply by 9, the 9 cancel. Then divide by 100, cancel here. So it becomes 1:4. Okay, so 1:4. So the answer is going to be C. Okay, let us proceed. Next question here. Question 1.6. Okay, that was 1.5. Yeah, 1.6 now. So 1.6 here it says what? Let's check it out here. They say here that the sketch, okay, the sketch below, the sketch graph below represents the relation between the ratio of the f listener, that observe frequency, to the source frequency, and the speed of the listener, VL, for the stationary source. They say that which of the following combinations correctly represent the value of P and the direction in which the listener moves? Now we want the correct information regarding what we see here. Okay, now if you check what we have here, we have f listener divided by f source, but what do we know from our theory? We know that from Doppler effect, which I think you guys know, our f listener, okay, is given by what? It's given by v plus or minus v listener divided by v plus or minus v what? V source times frequency of the source, So in this case, because I've got fl, so I have to divide by f source. It means I've got f source, f listener divided by f source, okay, equals to v. Now because there is a decrease here in this value here, it means here what must I do now? Because this one I must get a decrease in this, because of this decreasing gradient here, decreasing line. It means I'm supposed to do what? To subtract on top. I'm gonna say v minus v listener divide by v plus v source. Okay, v plus v source. Okay, so now in this case the question says the following. Okay, now what are we looking for? Check it out. We need the value of p. Now value of p here is the y-intercept, where t equals to 0. So at t equals to 0, it means we did not move yet, whereby f listener and the f source, they are equal. So in that case, my p must be 1. Okay, because we didn't move yet, so it means here p is 1. Okay. What about this side now? Now, because we are subtracting on top and adding at the bottom, you know from our theory that in this case, either the source is going away from the listener or listener going away from the source. What we have here, so direction is saying here, away from the source, towards the source, so away from the source. So it means in this case, because we got 1, and we have here away from the source, this must be the best answer. Why are we saying so? Because you know that because of this decrease here, we are forced to do what? To subtract on top, and then we are forced to add on top, on bottom, so as to conform to the decrease. And we know from our theory, this one shows us what? It shows us the listener moving away from the source. And this is one here. So the best answer is this one here. Okay, let's continue here. Next question here, 1.7. They said 2-point charges X, 2-point charges X with a charge positive Q and a Y with a charge of negative 2Q are by distance R. X exerts a force of F on Y. The charges on X and Y are each increased by 3Q. Which one of the following correctly represent the new force by the charge X on charge Y? So from Coulomb's law, what do we know, guys? That force is given by what? Equals to K times the charge on X, which in this case is Q, more Q positive altogether, multiplied by the charge on Y, in this case is 2Q, okay, divided by the distance squared. Distance was given here, it is R squared. Now what are the new changes? To get our new force, find out, let me call it F prime. Now the K is the same, the K is the same. Now this is that each charge increased by 3. So what is 3Q plus Q? Gonna give us 4Q, okay, that is 4Q. So multiplied by, so what is negative 2Q plus 3? It gives us Q, okay, gives us Q here. So distance was not changed, so this R squared here. Now if you check this side here, if I simplify the first one here, it gives us what do we get here? We get 2K, okay, this is 2K, then Q squared divided by distance squared, okay. Let's now check on how. So what do we get here? So gonna give us 4, it's gonna give us 4K, then Q squared divided by R squared, So to be the same as on here, we multiply by 2. We say 2 times 2K Q squared divided by R squared. So if you check this guys here, this one here, the same as our first force between the two charges, which means that our answer is going to be F prime, okay, equals to 2 times the first force F, so which is 2F here, okay. So we have such an answer here. So the answer is C. The answer is C here, 1.7. Answer is C. 1.8, what do we have here? 1.8. They said that in the circuit by the diagram below, VI is connected across a rheostat, that's variable resistor. Which one of the following sketch graphs represent the relation between the readings on V1 and V2 as the resistance of the rheostat is increased? I repeat, in the circuit by the diagram below, V1 is connected across a rheostat, which means variable resistor, which can be increased or decreased. Then this one here we have it as a constant resistor. Let's say which one of the following sketch graphs below represent the relation between readings on V1 and V2 as the resistance on the rheostat is increased. Now from our theory, when resistance of the rheostat is increased, we're going to have a higher total resistance for the circuit. I repeat, when resistance for the rheostat is increased, you're going to have a total increase in the what? In the resistance. Now, when the resistance increases, what happens to the current? You're going to have a decrease in the current. Are we together? So, because of a decrease in the current, and from ohm's law, the current and the potential difference, they are directly proportional. So, because of a decrease in the current, this V2 must do what? It must as well do what? It means that the V1, remember that the V1 it has been increased, okay? So it's gonna fall, okay? And in this case, as we do so, we're going to get our answer here. as now it can't be all of them increasing, so this B and D they are out, but because we are controlling this increase, okay, it means you're going to have it as what? As alternative A. So the best answer here is going to be A, because the increase is being controlled. Okay, next question here, that is that was 1.8. 1.9, do we have 1.9 anywhere? Let's check here. 1.9, where are you? 1.9, yeah, 1.9 is here, this one here. 1.9 and 10, they are here. Let's do them here like it is. Okay, so 1.9 says what? 1.9 says that a diagram, yes, the diagram below represents an electrical machine. Okay, so they say which one of the following represent the correct, which one of the following represent the correct type of the machine. So because we have got a battery here, then we have got the coil, the carbon brushes, the split rings, the magnet. So because of the battery, it means this cannot be a generator. Why? The generator produces electricity, so does not need it. So being a battery here, this must be a motor. And now a motor where we have the slip rings, that's called AC motor. But the motor where we have the split rings, that's called a DC motor. So in this case, our answer is going to be B, which says a DC motor. I repeat, because of the battery here present, it means it can't be a generator. Why? Generator generates electricity, okay, but the motor uses it, so we know it's a motor. Then here we know, because we don't have the slip rings here, it cannot be AC motor. Being with the split rings, it's called a DC motor. Hope we are together. I'm 1.10 here. They said that an atom in its ground state absorbs energy E and is excited to a higher energy state. When the atom returns to the ground state, a photon with energy, I repeat, an atom in its ground state absorbs energy E and is excited to a higher energy state. When the atom returns to the ground state, a photon with the energy dash is what? So, at first, during excitement, what happened? We got to a higher energy state. All together. Now, when you return now, you're going to, because when you went up enough from low to higher, we absorbed the energy. Okay, we did what? Absorbed the energy. But then now when you return, then now you the ground state, now you must release. So this is absorb, this is release. Okay, so in this case, and because we absorb the energy E, it means we must release energy E. So the answer is going to be B here. Okay. All right, let's continue with the other section now, which is not multiple choice. Okay. Where is it? Okay, this other section here, which doesn't have multiple choice. Where are you? Okay, it is just here, right here. Okay, so now this section here, what does it say? From Limpopo Trial 2024. Like I said, guys, if you can do this question without framework, you are sorted for November. Also sorted for May, June 2025. In case you're watching this after 2024. Okay, so here we have this question here. Question 2. What does it say? Question 2. Question 2 here, it says what? They said that a physics learner, I think must be from Rostec, pushes a 34-kilogram crate up the plane with a horizontal force of this magnitude F, okay? Then they say, as shown the diagram below, we see now our F is parallel to the what? Parallel to the horizontal. Are we together? What must we do? They say the coefficient of the kinetic friction between the crate and the surface is 0.25. suggest a reason as to why the coefficient of the kinetic friction is dimensionless. Now, it's dimensionless because the coefficient is a ratio between two forces. I repeat, we say it has no units because it's a ratio between two forces. You can say between the normal force and frictional force. We know from our Fk, if I may write this, we know from our Fk, right? From our Fk equals the coefficient times F normal. So from here, the coefficient mu k equals to the frictional force Fk divided by F normal. So now friction is measured in newtons. What about the force? Also newtons. So you see they cancel out. So that's why it's going to be dimensionless, this coefficient. So we say because it is a ratio between Fk and F normal. Next question here. What must we do? The crate moves up the plane at a constant velocity. State in words Newton's first law of motion. Now, if you watched our first video here, we stated all the laws of motion. If you don't have it, you can watch them now on our video. Check on our YouTube channel. That is Smart Physics. Smart Physics is a YouTube channel which we operate here by Rostec. Okay, so how do you state Newton's first law? A body will continue in its state of rest or motion at a constant velocity unless acted upon by a non-zero net force. I repeat, Newton's first law of motion, that a body will continue or will remain in its state of rest or uniform motion at a constant velocity unless a non-zero balanced force acts on it, or you can say non-zero net force acts on it. Okay, now they say draw a labeled free body diagram for the crate whilst in motion. Now a free body diagram means the diagram whereby the body, this body of the crate, we use a dot. Now as you can see guys, my plane is at an incline, right together. So this incline here, which looks like this. Okay, now with the drawing your free body, please always draw the surface first, so you can see what is happening. So as you can see, my surface is like this one here. Okay, so now the free body means you use a big dot to show the body. I repeat, if they say free body, use what? Use a big dot, are we together? To show the body, to show no body, to make it free from the body. So now, because we know it's a body of 34 kg, it has got weight. So this is my weight, which acts downwards. That's our weight Fg, which I think we are together for now. Okay, this is our weight W, or you can call it Fg, all together. Then being on the surface, it exerts a normal force. Now normal force in this case will mean that it is perpendicular to the what? To the surface. As you can see, this is perpendicular, so that's our F normal. That is our F normal. And then because it is moving up the slope, it means that it's opposed by frictional force, which is facing down the slope. Okay, so the frictional force is facing down the slope. Okay, hope we are together. That's a frictional force. In this case, it is kinetic frictional force. Now this is our normal force, which is F normal. Okay, this is our frictional force, which is Fk. By the way, if you use the standard labels like this, don't have to write them down. But now there's a force F here. Now this force F, on a free body diagram, we are advised to draw the arrow pointing away from the dot, from the free body. So in this case, our force F is going to be like this. And as you can see, it is parallel to the what? To the horizontal. So that's our force F. So I'm going to put my force F here like this. I hope we are together. Now after that, you can get an eraser and remove the plane, remove the surface. Okay, so here we go. Now that is our free body diagram. Hope we are together. Next question says what? Let's check it out here. They said that using an appropriate calculation show that the kinetic frictional force acting on the crate is what? Is 75,495 plus 0,106 F. Okay. Now you know what? This same diagram here, I can draw it showing all the components, okay? Like this. Check this out, guys. I know that like I said before, what is begin with what? Begin with our surface, okay, which was at an incline. Our surface was what? At an incline like this, okay. Are we together? Then from there now, what do we know? We know that we have the friction, the weight, okay, for this body here. Now this weight for the body, instead of drawing it like this, it has got two components, which I think you are aware of. The first component is called FG parallel, okay. It's called what? It is called FG parallel, like this, which is taking the body down the slope. That's our FG parallel. That's our FG parallel. You can draw it like this. This is our FG parallel. Okay. Then why doesn't allow to come like this? Okay, let me first move this slope here. You saw it already. Okay. Now this is my FG parallel here. FG parallel, which must come down like this. Okay. Now this FG parallel, it's taking the block down the slope altogether. Now the same block is being taken up by the what? By the component of this force which is going up the slope. So that's the component here, which is going up the slope. Now this component takes the body up the slope. Okay, that's the component there. And then apart from that, this was FG parallel. So I also have the what we call as FG perpendicular, which is acting opposite to the normal force. So this is my FG what? Perpendicular. Okay. That's our FG perpendicular. So this is FG. This is FG parallel. Okay. And this is FG perpendicular. Okay. And then this is our F normal. F normal. Are we together? And then what else do we have here? Also what we call as the frictional force, which is taking the block down. Okay. So frictional force is taking the block down. Okay, it's acting downwards. So this is a frictional force Fk. Now this is the component which is parallel to the slope. I will not call Fg, but I'm going to call it F parallel. Okay. Now the other component is acting on the body, because we remember this force like this, we are having the two components. One is acting perpendicular to the what? To the slope. This one here. This one here. Then the other is going up the slope like this. Going up the slope. Okay. So this one here is the F which is parallel, not FG, sorry. It is the F which is parallel. This is the F which is what? Which is perpendicular. So this F which it must come like this now from here. It must be our F what? Perpendicular. Okay, that's our F perpendicular. Don't know why it might think disappointing me now. But you see it should be just put here like this. Hope you want to confuse the two. So on top here, this is my F perpendicular. This is FG perpendicular. The two are different, This frictional force Fk. Okay. Now what do we know? What are we supposed to do? Check the question again. it says that what must we do? Using an appropriate calculation, show that the kinetic frictional force acting on the place given by this one here. Okay, so how define frictional force? Anybody who knows that? How define frictional force? Now the frictional force is given by the coefficient times normal force. But in this case, our normal force, as you can see, is exactly opposite F perpendicular and FG perpendicular. So we're going to say that coefficient, open brackets, the perpendicular force, okay, then plus FG perpendicular. FG what? Perpendicular, okay. Now, so we're going to say that our frictional force Fk. Now the coefficient was given to us, but we're going to put it later, no problem to that. Let us find F perpendicular. If you come to our diagram again, if this is 25, okay, so 25 here as well. Okay, 25 here as well. Now this F perpendicular here, as you can see, it's facing like this. This is F which is parallel, okay. So this 90 degrees here. Now this one being the opposite, mean that my F which is perpendicular is gonna be, I'm gonna use sine. I'm gonna say, if I say sine 25 equals to F like this, sine 25 equals to F perpendicular divided by the force F. So in the particular case where I have F perpendicular, I'm gonna say that my F perpendicular equals to F times sine 25 equals F times sine what? Sine 25. Hope we are together. So I'm gonna put it here. So this is the force F. This is the force F here times sine what? Sine 25. Okay. Then FG perpendicular, I think that one we know. We use MG cos 25. Okay. Let's now open brackets here. They gave us a coefficient here. Let's check it out, guys. Coefficient given to us. They say it is 0.25. Okay. What about the mass? It is 34. So calculators now. I need you here. So here I have 0.25. 0.25. Okay. Open brackets. The force F. Then sine 25. Okay. Now the mass is 34 times 9.8. Then times cos 25. Cos 25. So what do we get here? Open brackets and multiply. When you do so, you're going to get what? Calculators, help me out here. When you do so, what do you get? When you do so, here with my answers here, I can see that I'm getting 75, okay, 75, 495, 495, are we together? And then plus 0, 106 F, ne? I repeat this one for F, ne? I repeat this one for F. I get 0, 106 F, okay. Then this one here, 0.5 times this one here, I'm getting 75, what? 495. Hope we are together. That's our answer there. That's our answer there. I don't know if you have any question. All we are together. Okay. Let us proceed. Next question. Let us proceed. Next question. Yes, hello. Question 2.1.4. We've seen that our answer is this one here. Okay. Now they said that question 2.1.5. 2.1.5. It says that hence or otherwise calculate the magnitude of the force F. So we want to get this force F here. Don't forget that our body or our block is moving up the slope by what? By constant velocity, okay? By constant velocity, and meaning that it's going to be zero acceleration, okay? So why is it going up? It's going up pulled by this F which is parallel to the what? To the slope, and then opposed by FG parallel, also opposed by frictional force. So if I'm going to say this is 2, yeah, this is 2.1.5, I'm going to use F net equals to MA, F net equals to MA, F net equals to MA. Now our F net in this case stands for the force which is parallel, that is F parallel, okay, opposed by frictional force, okay, then opposed by FG parallel equals to MA. But because of constant velocity, it's going to be mass times 0. Because if the velocity is constant, then we have got what? 0 acceleration. Now, how do you find this F parallel? Check here. We said this is 25 and 25 here. So this F parallel is the adjacent, so we must use cos. So meaning our F parallel is the same as saying F cos of 25. So I'm going to put here F, the force F multiplied by cos of 25, okay, then minus frictional force, which is Fk, but Fk we see it is this one here, which we already proved, okay, so I'm gonna say minus 7, okay, minus 75, comma 495, okay, and then it's gonna be minus here, now minus what? Minus 0 comma 106 F, okay, then minus FG parallel. How do you find FG parallel? We know the mass is 34, eh? So it's gonna be mg sine, right? Mg sine 25. So we're gonna say minus mg sine 25, but the mass is 34. So minus 34 times 9,8, okay? Then times sine what? Sine of 25. Sine 25 equals to 0. Now correct like terms here. If you simplify here, this is f cos 25, then minus 0,106 f, okay? This minus 75 becomes positive this side. Also the f becomes positive, né? So when you simplify this on here with your calculator, what do you get? That is f cos 25, then minus 0,106 f. What do you get? Here I am getting 0,8. So here I get 0,8 with the f still, okay. Now after crossing equal signs, when I add 75,495 plus this answer from here, I'm getting 216,31, getting 216,3,31. Because I'm looking for the force F, so I divide it by 0,8, né? So my force F is going to be 216,31 divided by what? By 0,8. So what's our final answer here going to be? Calculators, check it out. Here it gives me 270,39 newtons. Okay, that's our force F for question 2.1.5. Hope we are together. Let's check what comes next. They say 2.2, the mass of the Earth is 5,98 exponent 24 kilograms, and the radius of the Earth is 6,38 exponent 6 10 powers exponent 6 meters. Then a small satellite that is 1,000 kilometers above the surface of the Earth is accelerating towards the Earth. The only force acting on the satellite is the gravitational force of the Earth. If the weight of the satellite is this one here, at 1,000 kilometers above the surface of the Earth, calculate its weight on the surface of the Earth. I repeat, the mass of the Earth is 5,98 exponent 24 kilograms. Are we together? And radius of the Earth is 6,38 exponent 6 meters. Okay, are we together? And then a small satellite that is 1,000 kilometers above the surface of the Earth. So the height from the surface of the Earth is what? Is 1,000 kilometers, and is accelerating towards the Earth. The only force acting on the satellite is the gravitational force of the Earth. If the weight of the satellite is 3660 newtons at 1,000 kilometers above the Earth, okay, so this is the weight at 1,000 kilometers above the Earth. Then they say that what must we calculate? Calculate the weight on the surface of the Earth. So I need to find the weight W, okay, on the surface of the Earth. Okay, so now let us have something here. Now you know what? If this is the Earth here, if this is part of the Earth, okay. Now this Earth has got distance from the center of the Earth, which you call radius of the Earth. So from this point up to here, this radius of the Earth, okay. I'm gonna call it radius of the Earth here. Are we together? From the center of the Earth, this is the Earth here. Then from the surface of the Earth, okay, to a certain height which is 1,000 kilometers above the Earth, that's where I have the satellite. So let's say it is somewhere here. From here up to somewhere here, that is where the satellite is, okay, at this point here. And they're saying it is 1,000 kilometers. Now kilometers to meters is going to be times 1,000, which makes it 10 to the power 6 meters. So my distance is here, 10 to the power 6 meters. That's mean from the surface to where the satellite is. If this is our satellite here, if this is the satellite you're talking about here, okay. And then they said at this point here where the satellite is, its weight is what? They said the weight there is what? It is 3600. So the weight at this point here is 3660 newtons, okay. So I'm supposed to look for the weight, okay, at the surface of the Earth here. So weight here, that's what I'm looking for. So now the question is, what is my weight here? Now what am I supposed to do? Now at this point here, I know that I don't know the mass of the what, of the satellite. So I'm going to find the mass of the satellite here so that I can use it to find the weight on the surface of the Earth, because I know weight equals to mg. Weight equals to what? 2 mg divided by g is 9,8. So here, let me find out the mass. But to find the mass, I need to know acceleration at this point here. So what do I do, guys? That is question 2.2. So we know that gravity at any point, I'm going to call it G prime, is given by the constant G times the mass of the planet, in this case is Earth, divided by the distance squared, okay? In this case, my G prime there is going to be given by, now the universal constant G, you can check there in your notes, it is 6, what? 6,67 times 10 power negative 11. I think that is it. If I try to remember, let me check it out now. Yes, it is 6,67 times 10 power negative 11. Okay. Then times mass of the Earth, they gave us here what? That is 5,98. So times 5 times 5. Okay. 0.98. Then times 10 power 24. Times 10 power 24. Okay. Power 24. Okay. Then divided by the distance from the center of the Earth to where the satellite is. So we must add the center of the radius of the Earth, which is this one here. That is 6, what? 6,38 times 10 power 6. Okay. And then the 1,000 kilometers from the surface of the Earth, which we said is 10 power 6 when we put it in meters. So plus 1 times 10 power 6. Okay. And then don't forget it must be squared. Okay, so here, calculators, what do you get here as our G prime? Gravitational acceleration. My calculator here, where are you? Yeah, so here, my calculator, it gives me 6,67 exponent negative 11, okay, times mass, that is 5,98 exponent 24, divided by open brackets, that is 6,38 exponent 6, then plus 1 exponent 6 as well, then squared, okay. It gives me here 7,32. So my graph there is what? 7,32, 7,32, then 34. Okay, so now I was looking for the mass, ne? So the weight of the satellite at that point equals to the mass times gravity d prime, ne? Now in this case, I'm gonna say the weight is said is 3 what? 3660 equal the mass which I don't know times this 7,32, then 34. So my mass equals to what? I divide now the 3660 divided by what? By 7,32, then 34. It gives me 498,41. So this is 498,41 kilograms. Ne? Now this mass is constant. So on the surface of the Earth, where I'm looking for the weight W, it's going to be weight equals to mg. But the mass now I know it is the 498, okay, comma 41, then times 9,8, because we know on the Earth's surface gravity is 9,8. Okay, so this answer times 9,8. What do I get? It gives me 4,884. So I get here 4,884, comma 39 Newton. That's now the weight of the same satellite on the Earth's surface. Hope we are together. Let us proceed. Next question here. That is now question 3. They say here that a ball is dropped from a height of 20 meters and rebounds with a velocity which is 3/4 of the velocity with which it hits the ground. The ball bounces 2 times as shown the position versus time graph below. So from this height here to the ground,
don't forget they
maximum
said that
height, ground again,
equal
maximum
positive
height.
charges,
Okay,
Q
this
and
is position
Q2.
in meters. This is
They are how
time
many
in
meters?
seconds.
0.02 meters apart.
What are we supposed to do?
This one
The
is
effects of air
0.02
resistance
meters
and the
apart.
time lapse
And then
with
they
ground
said
are
that
neglected.
what
We
happens
find
to
the term
them?
free
They said
fall.
that
So what is free
the
fall?
charge
Now
of
free fall
Q1
is
twice
motion
that
of a body
Q2,
which is
and the
only
force
influenced
between them is
by
what? It
gravitational
is
force.
9
I
times 10
repeat,
power negative 3
free
newtons.
fall is
Then
motion of
point
the
P
body
is
which is
0.02
only
meters
influenced
away. This point
by
P
gravitational
from
force.
Q2
Next
as in the
question here.
diagram
They
illustrates
say
here.
state the acceleration of
They
the
said
ball
that
the instant it reaches maximum height
7.1.2
after the first
they say
bounce.
here.
Now any
Calculate
projectile,
the net
whether
electric
in
field
the
at point
middle
P
or
due
maximum
to
height
charges Q1 and
or
Q2.
going downwards,
So
the
we want the E
acceleration
net
is
at
9,8.
P. We want what?
So
The
it's gonna
E
be what?
net at point P.
9,8
So this point P, we want the E net.
meters
Okay.
per second squared.
The E net
And
at
because they
P.
said acceleration, we know it's
So
a
now
vector,
for that matter,
so we should set
don't
downwards.
forget that
Okay,
our E net,
we should
our
set downwards. So
our E
it
net
is
at P,
9,8 meters
E
per
net
second
at
squared
P
downwards. Okay.
is given by the
Next
E,
question here,
the
3.3.
E due to charge
Calculate the time
Q1
interval between the
plus
first and
the
second
E
bounces delta TAB
due to charge Q2.
by using the equations of
But because we
motion.
don't know the charges
So we want the
yet,
time
let
delta
us first find the
TAB.
charges Q1 and Q2.
Now the time delta TAB
Now the
is
force
what we're
given here is
looking for.
Coulomb's force. The formula says
The
that
time from this point,
the force
up this
equals
point
to
here.
K
Now the logic here
times
is
Q1
we have the
times
remember it was being
Q2
dropped,
divided by what?
meaning V
By
initial
distance
is 0,
squared.
right?
Now the
V
force
initial
given
is
here
what?
is 9,
0.
okay?
So we choose down as
Times 10
positive,
power
okay?
negative 3,
If we choose down
okay?
as positive, then our
Equals
gravity
to
is what?
K. What's our K?
Our gravity is 9,8
times 10
positive, okay? Then
power
our change
9.
in Y,
Then our Q1
our
and
change in
Q2,
Y is going to be what?
they said
It's going
here
to be
that
positive 20.
now
Positive 20
because they
meters,
are
okay?
positive,
Then
positive
now we
charges,
don't know
all
the
of
time
them.
here,
What
but
do
we
we
need
do in this
velocity at
case?
point A. But
We're
they
going
said
to
that
say that our Q1
when you
is
find the
twice
velocity
Q,
of hitting
okay?
the ground,
Like you see it here.
let's say for
We're gonna
bounce, it's
say
gonna
our
be
Q1 is what? Is twice
3/4.
Q.
So let's first find the velocity at point A
Our Q1 is twice
by
Q.
using what?
Then our
By
Q2 is
using
just Q, okay?
V final
Divide by the
squared,
distance
okay,
squared, which is what?
equals to V initial
0,02,
squared
0,02,
plus 2A plus 2A.
but it must be squared,
Change in
okay?
Y. So V final is what
So
we're
we're gonna
looking
say
for.
here it's gonna
So
be
V final squared, as we hit
if
the
I cross
ground,
multiply here,
V initial is
and I
0
multiply
because
this one
it's
here,
dropped,
I'm gonna say that
plus
9
2A. Our
times
A is positive
10
9,8
power
net,
negative
because we chose
3,
down as
okay,
positive. The
times
change in Y
0,
is positive 20, so we
0,
can't
2
aggregate here.
squared, okay,
Calculators.
divided by,
what do we get here?
this
My
2,
calculator here,
okay,
I'm getting
10
my final
times
velocity
9
here as
times 10 power 9 equals to
392.
q squared.
So this is
Okay,
392.
now
This side,
calculators, get me the square
it is
root.
392.
What do you get here?
392 v squared
Now
final.
we
So what do
see
it now?
on
I
my
do
calculator
square root, ne? Then when I
the
take
q
my square root
squared,
here,
okay,
I get my v
the q
final as
squared
what?
equals to
As 14 root
the q
2.
squared, yeah,
14 root
the
2.
q squared,
Or you
q
can call it
squared
what? In decimals,
is
you
equal
can say
to
it is
2 times 10 power negative 16,
19,799.
2
You can say 19
times
comma what?
10
19 comma
power negative 16. So
799. Now they said that the
I need
velocity
to find
for
square root, square
bouncing
root on both sides,
is what?
square root,
Bouncing
okay.
is 3/4.
So what is our
Velocity
q
for hitting
equals
the
to?
ground. Next, so velocity
From
for
my
going up
calculator
now.
here,
Next, I'm talking about upward motion
I'm
from this
getting
point
my
to maximum
q
height.
as
Okay.
like this.
Now
My
this upward motion
q
here, velocity for
equals
going
to
up, they say it is
14,
what?
okay,
It's going to be now my v
14,
initial. It's going
comma,
to be the 3/4, okay,
142,
times velocity
then
for
times
hitting the
10
ground, which
to the
is 14 root
power
2. So
negative
what do we
9,
get here?
power
That is
negative
3/4
9,
times 14
okay.
root 2.
Now these
Here
are
it gives
coulombs.
me
After getting the value of
it gives
q,
me
I come back and get now the
14,85.
e due to p due to q and the q2, okay.
But I chose down
So
as
don't
positive,
forget
next
that
I make
we
it
said that
negative
our
here.
e
Now if I know the v initial
at
from this
p,
point,
okay,
and the maximum height velocity
the e
there
at
is what?
p
Is
equals
0,
to
right?
the e
So I'm looking for the
due
change
to
in
charge
time,
q1,
right?
okay,
So I can use
times
what?
the e
I can use
due to
v
charge what?
final,
q2,
okay,
divided by distance
equals
squared from
to
p, okay.
v initial
I beg your pardon,
altogether
yeah.
plus
Alright,
a
now how do you find
change
the
in time. Now the time
eq1?
is from a to p.
Now the e
Time is from where? From a
q1
to p, okay?
given by
Now v
k
final is 0 at maximum height.
times
The
q1
v initial is
divided by the
negative
distance
14,
squared,
negative
also plus k
14,85, okay?
times
Then
q2
plus acceleration is
divided by
also
what? By
positive
distance
9,8,
squared.
okay?
So in this
Then
case,
changing
don't forget our
time from
q1
where? From a to
replace q,
a
and we
to
just got
p. So
our
this
q,
negative
okay?
here becomes positive
Just
this
got our
side.
q
So my
as
change in
14,
time
142
from a
equal
to
negative
p
9.
is
Okay,
going to be
so
given by what? We
we're going to
divide.
say that our
Divide now
e
the
due
positive
to
14
p
after cosine cos 9.
at p equals to
Positive
k.
14,85,
Our k
okay,
is 9 times
divided
10
by the
the power
9,8,
9. Now it's our
divided by
q1.
9,8.
Now our
So
q1 said is twice
what does it give
q,
you
so it's
that
going to be
side?
2.
If
Okay,
I do so here, it
2
gives
times
me
our q, which is
it gives me
14. Okay, comma
it gives
142
1 comma what? 1
times
comma
10
52.
the power
Gives me
negative
1
9.
comma
Okay,
52.
then
1
divided by the
comma
distance, which
52.
is
Now this is the
now
time
distance from
from
q1 to
A to
point p.
P.
Let's
But the
check
question
it
about the
here.
time from A
Now
to B.
q1 to
Now
point
by
p is
time
0,
symmetry, the
0.04
time from
meters,
A to the
but must
maximum
be
height,
squared.
which
Okay,
is A to P, is the same as
0,
from maximum height
okay,
to B, which
0,
is from P to B. So the
0.04
times here,
meters,
they're equal.
but must be
So because I
squared.
want from A to
What
B,
about due to
I'm going to
q2? We're going to
say
say
that
k,
in this case, to answer my
k,
question
okay,
properly,
which is 9
I'm going to say that the
exponent
time
9.
from
Okay,
A to
we're going to
B,
say
which
k,
they
which is
want here.
9
So the
times
change in
10
time, okay,
the power 9,
change in time from A to
and then
B
I
is the
beg your
sum of the
pardon.
time from A to P, from A to what? From A to P.
Yes, we're
Then
saying
from
that
P to B.
9 times 10 power
But we
9,
have said that is the
10
same
times
time
q,
by time symmetry. So we're
q2.
gonna
Now
say here
q2 is the same as
1
q,
comma
so
5
I'm
2
gonna say
again plus
14,
what?
okay,
Plus 1 comma 5
comma
2.
142
Which answer do you get there? That side
times 10 power
calculators.
negative 9
Here it gives me 3,04
divided by the
seconds.
distance. Now the
3,
q2 from p,
04
let's
seconds.
check the distance
My answer
again.
there.
Now
Okay,
from
next
p,
question here.
from p to
What does it
q2, as
say?
you can see, 0.02
Sketch a
meters.
graph
I'm
versus
gonna say
time
here
graph for the motion of the ball from the
0.02
instant it is
meters.
dropped to
So
the
this
place reaches
is
maximum height after the
0,
first bounce.
comma
Clearly indicate the values of the following on the
squared.
graph.
Okay.
Okay.
Now
The
from my
times A
calculator
and
here,
P, velocity with which
my
it
e
is
at
bound,
p, let's
velocity with
find
which
out
it
here.
is bound.
My
Now
e
our
at p,
choice we chose down
calculators,
as
then what do you
positive, ne?
get?
And this ball was being
Here I
dropped,
get
right? So meaning that
9 exponent
because it was being
9
dropped,
times, open bracket,
our V
2
initial is 0, right?
times
V initial is what?
14,
Is 0.
comma,
So if the V initial is 0,
142
then
exponent
and the ball is
negative
going
9,
down,
okay,
Now, where the ball
then
is
divided
going,
by
that's where the velocity is facing
0,
as well.
0.04
So if I
squared,
chose
okay,
down as positive,
here it gives
it
me
means that my velocity for hitting the ground is going to be positive,
159097.
guys.
So for the
Do
first
you
one here, I
agree with
get
me?
15.
Now check this out. So if I happen to put my
okay,
y-axis here,
90,
okay, if this is my y-axis
and then
here,
97,
like it is,
97,
and then I'm going to put velocity
5,
here.
okay.
In what?
Here I get
Velocity
now,
in meters per
second
second. Okay.
Now here I
Velocity in
have
meters per
9
second.
exponent 9 again,
And then this
is
my
14,
0, okay,
142
my 0
exponent
here, this time axis
negative
here,
9 divided by 0,
together.
0.02 squared.
So this time in seconds here,
it gives me 3.
Then because it was blocked, I must
I
start
get
from
here
here.
3.
Now because I chose down as positive,
31,
it means the velocity for hitting the ground is going to be somewhere here, the positive side. So then now because they are both become like this, they're going to be in the same direction from somewhere here.
So
We just add them in this case. Okay.
Okay,
So this is my velocity for what? This is my velocity for hitting the ground. So
15,
that's velocity there.
90,
Now after hitting the ground,
97,
no, this was the 14
5.
root 2. Okay.
It gives me total
This
of
was 14 root
4,
2 here.
77292.
14 root 2.
So I have here what?
14
This
root
is
2.
4.
Then we lose some of the velocity, and then we are going to rebound from the ground. Now, when we bound from the ground, they said we are left with the 3/4 of the velocity. Okay?
Now E is measured
so the
in meters
3/4 now,
per what?
it must be less than what? Than this one here. So
Okay,
mean that
now because they are both
now
positive,
from leaving the ground to
it
the
means
maximum
that
height,
they are
velocity
repelling
is
the
0.
positive
So
test charge at
my
P.
graph must go
So it's
from
going
this
to be
initial
towards the
velocity, which is
east,
negative,
okay?
until
So we're
0.
going to say east
But the
here.
lines must be parallel.
We're going to say east.
Because they must all give us what?
We're going to say
Gradient
east.
of what? Of 9,8. So
that's our answer there.
It
The
must be 9,
inlet
what?
at P.
9,8. Okay, so
there.
in this case, this one is the
Okay, next
time
here.
there, and this is the beginning part. This is point where velocity is 0.
They're saying that
they said what must
that
we
is
indicate?
now 7 point what?
They said you must indicate what?
Yes, 7.2.
They said you must
Two smaller
indicate the
spheres
times
A
A and P. They are fixed in a place and
so the
supported by
time
2
A
is here.
meters in a
When we
vacuum.
hit the ground, this
Sphere
point
A has a
time
charge of
A,
positive 1,
then
equal to
P
negative
at
6,
maximum height should be
and
this
sphere
one
B
here.
has a charge
This
of
is
negative
P at
1,
maximum
equal to
height.
negative 6
This
coulombs,
velocity
as
for
shown in the
hitting the ground
diagram
we have
below.
it. When the velocity for
State
bouncing from the
in
ground,
words.
we go to
How
negative
do we
what?
state it?
We got
The electrostatic force between
negative
2 point charges is what?
something here which was
Directly
what?
proportional
Negative
to the
14,85.
product
Okay.
of
So
the
you
magnitude
have
of their
negative
charges
14,85.
and inversely proportional to the
Negative
square of the distance between their
14,85.
centers.
Yeah,
Okay.
that's what they wanted.
Then they say here calculate the number of excess
We are
electrons on
together.
sphere B. Now
Let us
sphere B, we need
proceed.
the number of excess electrons. How do we
Question
find
4.
them?
Because we
They
have
say
the
here
charges,
that
a
there,
ball is
we
falling
know that
freely when it's
all the
downward speed
charges
reaches
are
9 meters per second.
quantized, okay?
It explodes
Meaning
into
that
2 equal parts. Part 1 goes straight
we
up
can
to
say
a height
that
of
for any
13.7
given
meters
charge
above
on
the point
sphere
of
B,
explosion.
to find the number of
This is
electrons, we
before
say
explosion. This is after
that number of
explosion
electrons
here.
equals to the charge
Defined in words.
the charge
The
on the sphere B
momentum was applied in physics.
divided by electronic
What's
charge.
momentum,
So
guys?
we're going to say that
Momentum is the
it's going to be
product
N equals
of the
to,
mass
here they gave
and
us
the velocity
-1,
of an object.
0 times
I
10
repeat, momentum is
power
what?
negative
The
6.
product
Now
of
the charge of electron
mass
is how much?
and the
It's 1,
velocity
6
of an object. Ne? Then
times
4.2,
10
calculate the initial velocity of
power negative
part 1 just
19.
after
So
the
it gives us how many
explosion.
electrons here?
Okay,
Let's check it
the
here.
question again. A ball is falling
Calculators, what do you
freely,
get
so
here?
it's a projectile. Then when
We
when
have
its
1
downward speed reaches this one
negative
here,
6
okay,
divided
downward
by
speed there,
1,6 exponent
it
negative
explodes
19,
into 2 equal parts.
which gives us
Which
here
means if this is part 1,
which gives
we
me
put the mass m.
6,25,
It's going to be mass m here, part 2. Okay.
25
Then it
times
said that
10
part 1 goes straight up
power
to a height
12
of what?
electrons.
13,7 meters above the ground. Okay, so now this part 1, it goes to a certain
then
height,
7.2.3,
which is what? Which is
they say using a suitable calculation,
13,7 meters above the point of explosion. So
show
from here,
that the number of electrons
moves
that
up,
must
up this
be
point here.
removed from A,
Here, let's say
and they
that's
put
now the
onto B to
13,
make the electrostatic
that's now the
force that acts
13.
on each sphere.
the 13,7 magnitude is 45,7 meters equal to 2,59. About the point of okay. And then what must we find? They say calculate the initial velocity of part 1 just after the explosion. We want V initial here. Okay. Now what am I gonna do here? I'm gonna choose down as positive. So if I take a downward motion as positive, it means my gravity is what? My gravity is positive 9,8. Okay. Positive 9,8. What about my change in y? My change in y is gonna be negative 13 because it was going up. Negative 13,7 meters. Okay. What about my maximum height? V maximum, because it has maximum height here, V maximum is 0. Okay, so I'm gonna use what? I can use V final squared, okay, equals to V initial squared plus 2a change in y. So in this case, I'm gonna say 0 squared, okay, equals to, I'm looking for the V initial, né? Yeah, equals to V initial squared, okay, plus 2a, but my a is positive 9,8, okay. What about my change in y? Negative 13,7, negative 13,7. So here, when I multiply this 2 times 9,8 times 13,7, what do you get? What do I get here? In this case, with my calculator here, it gives me what? It gives me okay, also find the square root. Find the square root here. So my V initial, before I square root, okay, it gives me on my calculator here, it gives me 268, give me 268, comma 52, okay. Now I take square root, okay, square root both sides. So my V initial comes here, calculators, what do you get? Here it gives me negative 16,3866, negative 16, 3866 and 6. Okay. Now this is meters per watt per second. Now why am I putting negative? Because whenever I find a square root, I've got two answers, the positive and negative. But for me, remember I chose down as positive, and this thing was going up, so I must make it negative here. Are we together? So negative here means upwards. Because they said the velocity, I must tell them the magnitude and direction. So I'm gonna say it is 16, what? 39, 39 meters per second upwards. Okay, next question here. What must we do? That was question 4.2. Now 4.3. State the principle of conservation of linear momentum in words. How do we state it? State the principle of conservation of linear momentum in words. It says that the total linear momentum in a closed system remains constant. I repeat, the total linear momentum in a closed system is conserved, or you can say remains constant. Next question, they say 4.4. Calculate the magnitude of the velocity of part 2 just after the explosion. Now I want part 2 just after the explosion. So now this part 2 I see it's going down, part 1 goes up. So what happens just after explosion? What must I do here? Let's find out now. Now from the linear momentum conservation, we have said that the total momentum, okay, initial, the same as the total momentum, okay, final. Now at first the two parts were together, so I can say that M1 plus M2, okay, they were together. Remember the masses are equal after division, okay. They also had the same initial velocity, V initial, then later they split, giving us M1 V1 initial, okay, plus M2 V2 final. This must be final, not initial, sorry. This must be final here, okay. So I repeat here. So we're saying here that M1 plus M2 times V initial. They said equal parts, but that's why I'm putting MM, equals to M1 V1 final plus M2 V2 final. So now what is M plus M? I get 2M, okay. What was our V initial? I think they gave it to us here. Let's check it properly, guys. They gave us what here? They said that it was 9,2 meters per second. So going downwards, so it is positive 9,2. I'm going to put here positive 9,2. So this is positive 9,2. Okay. Then equals to M1, which is M. Now V1 final, that one which went up, we said this is M. Remember I said which is negative, ne? So negative 16,39, okay, 39. Then plus M2, which is M. Now I want this speed here. I'm gonna call it V2 final. Okay, so now if I check this one here, what is 2 times 9,2, guys? 2 times 9,2, 2 times 9,2. Yeah, it gives me 18,4. So here I have 18,4. I have 18,4 M. Okay. Now this minus makes it to be positive, so it becomes plus what? Plus 16, comma what? Comma 39 M. Okay. Equals to M times what? Times V2 final. So what is 18,4 plus 16,39? What do you get? Here it gives me 34,79. So I get 30 what? I get 34,79. 34,79 equals to, this is M here, don't forget, equals to M2, then V2 final. So divide by M both sides, okay. So the M's are gonna cancel here, they're gonna cancel here. So in other words, my V2 final equals to 34, okay, 79 meters per second downwards, because they said the magnitude, don't tell them about downwards. So that's my answer here, and I hope we are together. Okay, next question here, that's question 5. What does it say? Let's check it out. Question 5 is from we can get the power here from Limpopo 2024. They say that a truck of mass 6,000 kilograms accelerates from rest at the top of the slope to 11 meters per second at the bottom of the slope. The slope is 480 meters long and the truck starts 55 meters above the level ground as shown in the diagram below. So it's our truck here on the incline accelerating until it is what here? 11 meters per second, then continues with this on this arrestor bed here. The height is 55 meters above the ground. There's a theta here. They say that the average frictional force on the truck during the journey down the slope is what? It's 3,84 exponent. I repeat, the average frictional force on the truck during the journey down the slope is what? Is 3,84 exponent 4 newtons. They say classify frictional force as a conservative force or a non-conservative force. Now, frictional force is a non-conservative force. Why? Because a non-conservative force is a force whose work done to move an object between 2 points depends on the what? On the path which is taken. So frictional force depends on the path. That's why it's got coefficient, okay? So it is what? It is a non-conservative force. It is what, guys? It's a non-conservative force. Next question, they say here that what must we do? Define in words the term power as applied in physics. Now, power is the rate at which work is done. Power is what? The rate at which work is done. Power is the rate at which work is done. Rate at which work is done, okay? That's power, okay? Or you can say power is the rate at which energy is expended. All right, now they say calculate the power is produced by the engine if the truck takes 88 seconds to reach the bottom of the slope. I repeat, calculate the power produced by the engine if the track takes 88 seconds. The track takes what? 88 seconds to reach the bottom of the slope. So what do we do here? Now in this case, okay, what do we know? That power is what? Power is given by the work done, okay, by the force of the engine. In this case, I call it applied force, divided by what? By the change in time. So now this track is accelerating downwards, né? So I'm going to use work net equals to change in EK. If I use work net equals to change in EK, so what is my work net gonna be? I'm going to have the work done by the force of the engine, which I'm calling applied force, because it is what? It is accelerating. Then remember, there's also FG parallel, it's also plus work done by FG parallel altogether. Then plus work done by frictional force, that is Fk, equals to what? Equals to a half, okay? And we're gonna say V final squared minus what? Minus V initial squared. Minus what? V initial squared, but said from resting, okay? Minus V initial squared. So minus V initial squared. Let me now substitute. Now I'm looking for this WF so I can come back to get my power. So when I say WFA, okay. Now how do you find FG? We use mg sign, okay. It's gonna be now mg. When I say this is mg sine theta, okay. Then times displacement, then times cos of theta, okay. Then for the friction, I'm gonna say Fk, okay, times displacement times cos of theta as well here. Then I'm gonna say equals to a half, equals to a half, open brackets. So the half m is a half m, open brackets, v final squared minus what? V initial squared. Okay, so in this case, what do I have here? Okay, let me check it out here. Now the WF is what I'm looking for when I say WFA. Okay, what about the mass of the truck? The mass given to me was what? Let's check it out here. They said the mass of the truck is let's check it here, 6,000. Okay, so I'm gonna say 6,000, right? I'm gonna say this is gonna be 6,000 here, but what I know, okay, is 9,8. So I'm gonna say this is 6,000 here. This is 6,000 times what? 9,8. Okay, then times sine of theta. Now sine theta is opposite over hypotenuse, ne? So it's gonna be times 55, okay, times 55 over 480, then times displacement, which is a 480 again, times 480, and then times cos of what? Times cos of 0, because FG parallel is going down the slope, ne? So it's going to be cos of 0 here. Are we together? I go now to friction. Now friction force, they gave us a value here. They say it is 3,84 exponent 4. So we're going to say here 3,84. So this is 3,84 times 10 to the power 4. Then times displacement, which is also forward 480. Okay, that's Fk times displacement, then times cos of theta. Now the cos for the theta for friction is 180, ne? So we're gonna be times cos 180. Okay, then equals to what? Let's check it out. Equals to a half. Yes, equals to a half. That's equals to 1/2. Must give us 6,000. 6,000. Open brackets. V final, they gave us it was 11, right? That's 11 squared. Okay, minus 0 squared. Okay, so let's get them one by one. So WFA is not changing. Then WFA is not changing. Okay, So I have here WFA, that's applied force, the force of the engine, okay. W force of the engine, then plus what? Let's check it out here. Calculators, that is 6,000, okay. 6,000 times 9,8, okay. Then times 55 over 480, over 480. Then times 480 again. Then times cos of 0. So here it gives me 3,234,000. I get what here? I get 332. I get here 3 what? I get 32. I get 32. And then what? 3,400. Another 0. Okay. And then now the frictional force here. Work by frictional force here. My calculator, it gives me 184. 184 32, okay, 3200, and then equals to this other side here. On my calculator, it gives me this side here, this one here, it gives me here it gives me 363,000. Gives me what? Gives me 363, then 000. Okay. All right. Now, in this particular case, collect like terms. I'm looking for WF8 to get power. So I'm gonna say this one becomes a positive, so it becomes a minus here. So finally, here I'm gonna get my work done by the force of the engine. Okay, equals to 15. Okay, again 5 here, 61, and then 0, 0, 0. So because I'm looking for the power, we say the power equals to work done over change in time, in this case by the force of the engine, which is now going to be 1 5 5 6 1 0 0 0 divided by what? By it give us 88. So on my calculator here, it gives me 1768, and then 29 comma 55 watts, comma 5 watts. So that's our power. Okay, hope we are together. I hope we are together, guys. Okay, that was it there. Then they say here that at the bottom of the slope, the truck cannot stop and enters a gravel arrestor bed. The bed is 20 meters long and provides a resistive force of what? 0.35 times the weight of the truck. Use calculation to determine if the bed is long enough to stop the truck. I repeat, they're saying here that at the bottom of the slope, the truck cannot stop and enters a gravel arrestor bed. The bed is what? 20 meters long and provides a resistive force of 0.35 meters, 0.35 times the weight of the truck. Then they say, use a calculation to determine if the bed is long enough to stop the truck. Okay, so we're going to find out if our stopping distance is more than 20, then the bed will not stop the truck. If the stopping distance is less than 20, then it's good. The truck will stop. Let's find out here. Now in this particular case, we can use what can we use? If we use, because we want it to stop, meaning RV final must be what? Must be 0. Okay. Now V initial, we know it is the 11, the 11 meters per second. Okay. All together. Then the resistive force in this case means frictional force. The frictional force in this case to stop the truck that we are looking for is going to be 0.35. They said 0.35 times the weight. Now the mass of the truck was what? It was 6,000. So we're going to say times what? Times 6,000. Okay. 9,8. So what do we get there as our frictional force there, or the resistive forces? I'm gonna say 0,35 times what? 6,000 times 9,8. Yeah, it gives me 20580. It gives me to what? 205, okay. Then 80. Okay. So I'm supposed to use V final squared, okay, equals to V initial squared plus 2A change in what? Change in X, okay. So I don't have acceleration, but I can use anyway, I can use W and C. Yes, I can use W and C, okay, equal to change in what? Change in EK, okay, change in EK. So that the work done by the frictional force, okay, by the frictional force equals to I have here M into what? Into V final squared minus V initial squared, okay. So what am I gonna do? I'm gonna say the frictional force Fk times my displacement I'm looking for, okay, times cos of theta equals to 1 over 2 times the mass, okay, into V final squared minus V initial squared, okay. So here we go. What's our Fk here? We got 20 what? It is 2050 2050. I mean 580. You're looking for this delta x here, okay. Then our theta is gonna be cos 180, 180 because friction is what? Is acting the opposite direction, okay. Cos 180 here. Then equals to 1 over 2. The mass we know is 6,000, okay, 6,000. Now final velocity it must be 0 because we want it to stop, that is 0 squared minus 11 what? 11 squared. So what do we get here? Now this is gonna be cos 180 is -1, then times this one is gonna be negative. It's gonna be negative. What's gonna give us negative 20580 delta x, okay, equals this side we get what? That is a half, which is 0,5 times 6,000, okay, times negative 11 squared, okay. What do we get here? It gives us negative 363000. Negative what? Negative 36, negative 36, and then 3000. So how do you find out delta x here? So our delta x, the stopping distance, okay, equals to the negative 3, okay, 6 is 3, and then 000 divided by what? Divided by negative 20580 gives us what? Check it out here. Divided by negative 20580. It gives me negative 17,64. So because the 17,64 is less than the 20, mean that our Aristotle will stop the track. So the answer is yes. The answer is what? It is yes, because the stopping distance is what? Is less than 20 meters. So the answer is yes. Okay. All right, let us continue here. Next question here. Question 6 here. They say that a commuter train passes a passenger platform at a constant speed of 40 meters per second. The train horn is sounded at its characteristic frequency of 320 Hz. Take the speed of sound in air to be 340 meters per second. State Doppler effect in words. How do we state it? Doppler effect, how do we state it? The change in the what? In the perceived frequency or pitch of the sound source as detected by the listener due to the different velocities between the sound source and the listener relative to the medium of sound propagation. Next, calculate the frequency heard by a person on the platform as the train approaches the platform. Now, from our Doppler equation, if the train is approaching the person who is stationary, what do we expect? We expect a bigger F listener. We expect a bigger what? A bigger F listener. So, because of the bigger F listener, it means in our Doppler equation, we're supposed to add on top, okay? We're supposed to add on top, and then we subtract at the bottom, okay? Then times what? Times F source. So in this case, our F listener, let's check here. Now the V given here is what? It is 340. We're going to say 340 here. Then your stationary, so plus 0 divided by what? By 340. Now the sound source was moving train, which is 40 meters per second. It's going to be here minus 40 altogether. The frequency was 3 what? It's 320 here. That time 320 here. So what's our final answer here? Going to be F listener calculators. Let's check it out here. So here I have 340 multiplied by 320 divided by 340 minus 40. Here it gives me 362,67. I get what? 362,67 Hz. That's now the frequency which is heard of the listener on the platform. Let's say capture the wavelength detected by the person on the platform as the train approaches. Now, if you know the frequency, we use V equals to F times lambda. Lambda is wavelength. So the V is the 340, okay, the speed of sound in air. The frequency we have here is what? As 362,67. We're looking for this wavelength, ne? So divided by what? Divided by 362 both sides, 67. Divided by what? By 362, 67. So what's our lambda going to be? Our lambda, the wavelength, is going to be equal to what? There, we can say 340 divided by this answer here, 0.94 meters. So here we have 0.94 meters, 0.94 meters. That's our wavelength. Okay, next question here. That is 6.2. 6.2. They say that a motorcycle starts from rest, meaning V initial is 0, and accelerates along a straight line at 2.81 meters per second squared. The speed of sound in air is what? 343 meters per second. A siren at the starting point remains stationary. Use a suitable calculation to prove that the distance that the motorcycle has traveled. When the driver hears the frequency of the siren at 90% of the value it has when the motorcycle is stationary is what? Is 209.34 meters. I repeat, they said that a motorcycle starts from rest and accelerates along a straight line at what? 2.81 meters per second squared. The speed of sound in the air is this one here. A siren at the starting point remains what? Stationary. Use a stable calculation to prove that the distance that the motorcycle has traveled when the driver hears the frequency of the siren at 90% of the value it has when stationary is what? Is 209.34 meters. So now in this question, I'm going to first find out my V for the listener, okay? Because if I find it out, that will be my final velocity when it's first somewhere from the starting point, okay? So from Doppler equation, because listener is moving away, we're going to say that F listener, okay, F listener equals to V minus V1, V listener, divided by V plus V source, okay, times what? Times F source. But this F listener is at 90%, that means 0.9 of F source, okay? Now the V here given to us is 343. They said 343, okay? Now this person is moving, that's a VL is not 0. but the source is 0. It's going to be now 343 plus 0, okay? Then times what? F source. Now, if I divide by F source, it's going to cancel out. So, mean that I can find my what? My V listener. So, I'm going to say 0.9 multiplied by 343, okay? 343 equals to what? Equals to 343 minus what? Minus V listener. So in this case, V listener becomes positive, ne? That my V listener is going to be what? V listener equals to the 343, okay? 343 minus what? Minus 0.9 times 343. Okay, so what's our answer here? Somebody with a calculator, please help us out. 343 minus 0.9 times what? Times 343. What do we get here? Here I get 34.3 meters. I get 30 what? I get 34.3 meters per second. Now this VL is the same as the V final. So my V final is going to be what? 84.3 meters per second. Now remember to start from rest, ne? Meaning V initial was what? Was 0, like we said here. And then what are we looking for? Is accelerating, ne? Give us acceleration as what? Give us as 2.81, okay? 2.81 meters per second squared, okay? We're looking for the change in displacement, okay? So we can use V final squared, okay? Equals to V initial squared plus 2a change in x. So we find out this guy is having 34, 3 what? 34, just 3 squared, okay? The v initial 0 goes from rest here, plus 2a, we know the acceleration is 2.81, then times our delta x, which we're looking for. Now from my calculator here, delta x equals 2, let me find out here. So we're going to divide, that is 3,43 square, 34,3 squared divided by 2 times what? Times 2.881. It gives me here what? 209.34. 209.34 meters. I think we are correct. That's what they said here. 209, yeah, we are correct here. That is it there. Hope we are still together. Our next question on the queue here, that is question 7. What does it say? From Limpopo 2024. They say here that two unequal positive point charges, Q1 and Q2, are 0.02 meters apart, as shown in the diagram below. You see this right here. Then they say the charge of Q1 is twice that of Q2, and the electrostatic force that each charge experiences is what? Is 9 times 10 power negative 3 newtons. And then they say point P is what? 0.02 meters away from Q2, as diagram illustrated shows below here. So this is Q1, Q2, 0.02 meters, point P here. Define in words the term electric field at a point in space. How do you define electric field at a point in space? Now, electric field at a point in space, how do you define it? Okay, they want it in words. Electric field at a point in space. So, this is what we do here. Before you get it, write this equation here. Now, so that electric field at a point in space is the electrostatic force which is experienced per unit positive charge placed at that point in a field. I repeat, electric field at a point in space is the electrostatic force which is experienced per unit positive charge placed at that point in the field. Next, calculate the net electric field at point P due to charges Q1 and Q2. So I want to find the E at point P, okay, due to what? Due to charges Q1 and Q2. So what do I do here? Now, before I find the electric field at point before Q1 and Q2, I need to know the charges. So what must I do now? I need to know the charges. Okay. Yes. Again, let's read the question again. 7.1.2. They are saying here that two unequal positive charges. Two unequal positive charges. Okay. Q1 and Q2. They are 0.02 meters apart. We see that here, as shown in the diagram below. Okay. And then they say here that the charge of Q1 is twice that of what? That of Q2. The charge of Q1 is 2 times that of Q2. And then they say that and the electrostatic force that each charge experiences is 9 times 10 power negative 3 newtons. Point P, this point P here, is 0.02 meters away from Q2, as the diagram below illustrates. Okay. Define in words, this one we are done with it. Then they say, calculate the net electric field at point P. Okay. Calculate what? Calculate the net electric field at point P due to charges Q1 and Q2. Okay. Due to what? Due to the charges Q1 and Q2. This Q1 and Q2. So now we are going to use the formula which says that the E net, okay. So the E net at point P is given by the E due to the charge Q1 plus the E due to the charge Q2. So as you can see, I need to be knowing my charges Q1 and the Q2, and hence I have to use this force now to find out the charges of Q1 and the Q2. But because it is a force from Coulomb's law, the formula says that that force is given by K, okay, times the charge Q1 times charge Q2 divided by the distance squared, okay. Now they say that Q1 is twice Q2, so I can say that let my charge Q1 and Q2 equal to Q. So therefore, my Q1 is going to be 2 times Q, okay. So the force given to us here is what? It is 9. It's 9 times 10 the power negative 3 newtons, okay, equals to K, but our K is 9 times 10 to the power 9, then times Q1. Q1 is 2Q, right? Is 2Q, as we have said it there. Then times Q2, which is just Q, okay. So now divided by the distance squared. Distance here, it is 0.02 meters, but don't forget we are supposed to do, supposed to square 0.02 squared. Okay, so from here, as you can see, I'm going to say that in this case, I multiply this force times denominator divided by this one on top here. So in others, I can say that my force, that is 9 times 10 the power negative 3, right, times the denominator, and that is 0.02 bracket squared, okay, right here. Then divided by the numerator, this side of Q, I'm starting with a 2, that is 2 times 9, okay, then times 10 to the power 9. So what is Q times Q? I get Q squared, okay. So here now, if I multiply this side on my calculator, what do I get? Let me find out now. So I'm gonna say 9 exponent negative 3 times 0.02 squared, okay, divided by 2 times 9 exponent 9. So here it gives me 2 times 10 power negative 16. So this is 2 times 10 power negative 16. Now this one is equal to q squared, okay? But I need to find the q, so I do what? I square root, guys. Square root. So if I do so here for the square root with my answer, it gives me 14,142 times 10 power negative 9. So I have here, I have 14, my q, okay, is 14, 142 times 10 the power negative 9 coulombs. Now that's my q. After getting my q, now I come back to this equation here. Let me call it equation star to find out my innate. Okay, so we have said that our innate is given by the sum of those innate, those EQ values because of 1 and 2 q's. Okay, so now my innate at p. Okay, so my innate equals to k. Now eq1 is given by k times q1, okay, divided by the distance squared, then plus k times q2, okay, divided by the distance squared as well. So now our k, we know it is 9 times 10 to the power 9, okay. What about our q1? We said the q1 is the same as twice q, so we're going to say times 2 times the value of q, which we just calculated here, that is 14, okay, 142 times 10 power negative 9. What about my distance from q1 to p? It is 0,04. So when I say 0,04, 0,04, but it must be squared, right? So squared here. Then plus the e due to the charge q2. Plus what? Plus e due to charge q2. Okay. So we say here plus. Now again, we're going to say our k, that's 9 times 10 to the power 9. Okay. Then times q2, which is the same as this q, and that is going to be 14, 142 times 10 the power negative 9, okay, divided by, now distance from of q2 to p, let's check it here. Now from q2 to p, it is 0,02 meters. I think it's right, guys. 0,02 meters. 0,02 meters, but must also be squared. Okay, so here I'm going to get my innate. Now for this first one here, what do I get? Calculator. I'm going to say fraction 9 exponent 9 times 2 times 14, 142, okay, exponent negative 9, okay, then divided by 0,04 squared. So here on my calc it gives me 159097. I have here 15, okay, then 90 and then 97, okay, and then comma 5, okay, comma 5. Then this other one here on this other side of q2, again 9 exponent 9 times 14, 142 exponent negative 9, okay, divided by 0,02 squared, it gives me 318195. I get here 318, okay, 195, okay. Now because of these two charges being positive, they're going to be producing the E at P, which is in the same direction. So we are going to add these two values, okay, because they're all positive. We're going to be pairing the positive test charge put at P. So if I add the two values here, I'm getting here the 47792.5. So I get here what? I get my E at P as what? As 477292292.5, okay, 5 newtons per coulomb. You can say to the right. Okay. Did they want magnitude, or let's check without magnitude? What do they want here? They didn't, so we must say to the right. Okay, that is it there. Then another question here, 7.2. They said that the two small spheres A and B are fixed in place and separated by 2,0 exponent negative 2 meters in a vacuum. Sphere A has a charge of positive 1 exponent negative 6 coulombs, and the sphere B has a charge of negative 1 exponent negative 6 coulombs, as shown in the diagram below. So this is sphere A, this is sphere B. They are 0,02 meters apart, let's say. State Coulomb's law in words. How do we state it? Coulomb's law. So that the force that one point charge exerts on another point charge is what? Directly proportional to the product of the magnitude of the two charges, and inversely proportional to the square of the distance between their centers. I repeat, Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to the product of the magnitude of their charges and inversely proportional to the square of the distance between their centers. In other words, we're talking about something here. Now, this is Coulomb's law in a formula, but then we get it in words like the way I've told you. Okay. All right, next question here says that what is the number of excess electrons on sphere B? Now, sphere B, to get the number of excess electrons, we know any charge is quantized. So we're going to use N equals the charge on B, okay, divided by electron charge, okay. Now the charge on B they are given to me is what? It is negative 1, 0 times 10 to the power negative 6, okay. Then divided by the 1,6, okay, 1,6 times 10 power negative 19, okay. It's also a negative, so put a negative here. So sphere B has got how many electrons? Let's find out here. So from my calculator here, I have 1 exponent to negative 6 divided by 1,6 exponent to negative 19. So it gives me 6,25 exponent 12. So I get what here? 6,25, okay, exponent 12. Now these are the electrons which are on sphere what? Sphere B. Okay. Next question. They say here that using a suitable calculation, show that the number of electrons that must be removed from A and put onto B to make the electrostatic force that acts on each sphere an attractive force whose magnitude is 45 newtons equals to 2,959 exponent 12 electrons. I repeat, using a suitable calculation, show that the number of electrons that must be removed from A and put onto B to make the electrostatic force that acts on each sphere an attractive force whose magnitude is 45 newtons, and those electrons must be equal to what? To 2,59 exponent 12 electrons. Okay, let us check this out. Now look here, guys. You know what I have here? We can see that on sphere A, the initial charge is 1,0 exponent negative 6 positive. Even here it is negative 1,0 exponent negative 6 coulombs altogether. Now because we have the same magnitude, okay, I'm gonna say that let the final charge on A be equal to Q as well as on B. Remember that here, because the magnitude is the same, and what we are taking off here, we are adding it here. So they're gonna give us the same charge afterwards. Okay. So in other words, I'm gonna say that the new force, which is attractive, will be given by this formula here. So the new attractive force, okay. Okay. Don't forget to say that let Q equal to our final charge, afterward, after removing the electrons, okay. after removing the what? The electrons. Our final charge after transferring the electrons. Okay. Okay, now the force attractive is given by force equals to K, okay, times the charge Q1, okay, times the charge Q2, divided by what? By the distance squared. So in this particular case, the force given is 45, right? We're going to say 45 newtons, okay, comma 0, okay, equals to K, that's 9, times 10, the power 9. Now the charge on Q1 is Q, also Q2 is also Q, divided by the distance squared, which is 0,02, 0,02 squared. Okay, so now here I'm going to say 45 multiplied by the denominator, that is 0,02 squared. Okay, then divided by this one here, which is the 9 times 10, the power 9 equals to Q squared. Okay, so what's my Q after taking the square root? Okay, even before the square root, what's our Q here? So we're going to square root both sides. So on your calculator, please help me and find this value here. Okay, my calculator here, it gives me, let me check it out here. I get the 45 times 0,02 squared divided by 9 exponent 9. It gives me 2 times 10 to the power negative 12. So under root here, it is 2 times 10 power negative 12. Then square root of that answer, it gives me 1,4142. It gives me 1,4142 times 10 power negative 6. Now this is the new charge of attract after the transfer of electrons. So once we have the new charge and we have the initial charge here from sphere A, then we can find out the change in the change in charge and hence the number of electrons which have been transferred. I repeat, once I have the final charge, okay, this one here, and together with my initial charge, I'm going to get the number of electrons by saying equals to the change in the charge divided by what? Electron charge. So how do you find the change in the charge? Final charge, okay, minus what? Minus initial divided by what? Electron charge. Okay, so what's our final charge? That is 1,42, 1,4142, okay, times 10 the power negative 6, then minus initial charge, which was 1,0 times 10 the power negative 6, then divided by the 1,6, okay, times 10 power negative 19. So how many do you get there on your calculator? Okay, here on my calc here, if I punch in numerator 1,4142 exponent to negative 6, okay, minus 1 exponent to negative 6 divided by 1,6 exponent to negative 19, it gives me 2,58875 exponent to 12. So it gives me what? It gives me 2,5, okay, 88 75 times 10 to the power what? The power 12. Now if I look at the given answer, they want this one here. So if I round off here, it's gonna be exactly what? It's gonna be exactly 2, what? 2,59, okay, 2,59 times 10 to the power 12 electrons. Okay, all right, hope we are together. Let us continue. Next question here. That is question 8 from Limpopo 2024. What are they talking about here? They say that In the circuit shown in the diagram below, the reading on ammeter A1 is double that on ammeter A2. And reading on the voltmeter V2 is 3 times that on the voltmeter V1. So I'm saying here that ammeter A1 is double on ammeter A2, this A2 here. And then they say here that also the reading on the voltmeter V2, this is V2 here, is 3 times that on V1. Okay. All right. Then so what was we find? This EMF here, this is 20,4 volts. We don't have a down resistance here, but we have this 9 ohm in series. They say that the battery has an EMF of 20,4 volts and an unknown internal resistance. Okay. 8.1. Define the term EMF of a battery. Now, EMF of the battery is defined as the what? The total electrical energy a battery can supply per coulomb charge. I repeat, EMF is defined as what? The total electrical energy that a battery can supply per coulomb charge. Now, 8.2, they say calculate resistance of resistor 1. Okay, we need to find this resistor 1 here. Now, resistor 1 to find it, that's what we are looking for. Let's check it properly. Okay, now resistor 1, if we can see here, it is in a series with a 10 ohm, and this combination is in parallel with the what? With resistor 2. Are we together? Okay, now because this is a parallel combination, this one here is what? It is a parallel combination together with this one, this resistors, okay? It means that I know that in that case, my V, because they are parallel, my V parallel, okay, will be the same as V2, whereby V2 will be the same as the V1 altogether plus the V across the 10 ohm resistor. Why? Because they are in parallel. But what did the question tell us here? They said that reading on V2, okay, is 3 times reading on V1. Are we together? So, because I'm looking for the resistor 1, I'm going to use V1 here. And I'm going to put V2, I'm going to put 3 V1. So I'm going to say here that 3 V1, right? Because we are saying that that's from this given information here, right? 3 V1 equals to V1 here, okay, plus the current I times what? The 10 ohm resistor, okay. So what is 3 minus 1? I'm going to get 2 V1 equals the current I times 10 ohms, okay. But then, what do I know about V1? V1 is the same as the current I times resistor 1 from Ohm's law. So 2 times the current I times resistor 1, which I'm looking for, equals to I times 10. Why am I saying so? You see, guys, this is the same line, okay? It's the same what? This is the same line here. So because the same path, my current passing through the resistor 1, the same current passing through the 10 ohm resistor. So that's why it is I here. So if I divide by 2I both sides, I can get my resistor 1. Okay, if I divide by what? I divide by 2I, even here divided by 2I, okay? So my resistor 1 equals to 10 over 2, which gives me 5 ohms. Hope we are together. Next question here. That's now question 8.2.2. Resistor 2. Resistor 2. I want to get my resistor 2 here. How do we do it this time? Now resistor 2. Now they said that the reading on ammeter A1. Let's check it again here. On ammeter A1 is double that on ammeter A2. Are we together? reading on ammeter A1, this A1 is double reading on ammeter A2, okay? So mean that the current which is passing here, you see this is ammeter A2, ne? The current passing here, okay, is going to be the same as the current passing here, because this one is double and this is a branch, okay? We know that if this is the current, if this is the main current I, okay, right together, and this is I1 passing here, and this is I2, we know that because these two are, there's a branch here, we know that our current I, okay, equals to I1 plus what? I1 plus I2, we know that, right? But because they said this is double, it means that I can say that my current I, actually it shows us that the current I1 is the same as current I2 because it must be double to give us the I. Okay, let us now proceed here. So to get my resistor 2, because we have seen that the currents are equal here, and we have seen that also that the V2, okay, V2 is equal to the V1, are we together? Then plus what? Plus the V across the 10 ohm resistor, again, like we said, okay? So what is V2? That is the current I2, okay, multiplied by resistor 2, which I'm looking for, equals to V1. What is V1? The current I1, okay, times resistor 1, which I got as 5, okay, plus what? Plus V10 is down the current I1 again, okay, times the 10 ohm resistor, okay. But we have said here that I1 equals to I2. So therefore, guys, I don't know if you see this, but these are like terms now. So I have I2, okay, I have I2 times resistor 2. What is 5 plus 10 equals to 15 I1. But because I2 equals to I1, it means that I can say that I1, okay, times resistor 2 equals to 15 I1. So divided by I1, divided by I1, both sides, okay? So my resistor 2 becomes what? Becomes 15 ohms. Becomes 15, so this 15 ohms here for resistor 2. So this was 8.2.2 for resistor 2. Okay. Alright, let us continue then. Next question here. Let's reading on V2 is 9 volts. Calculate the potential difference across the 10 ohm resistor. Okay, so they're saying V2 is 9 volts. So we need the potential across the 10 ohm resistor. Okay. Okay, they said here what? That the reading on V2 is 9 volts. We need the potential across the 10 ohm resistor. So what do we know here? Let's check it out. Now, if you look at our diagram again, our V2, okay, our V2, this is now question 8.1. It is 8.3, right? Let's check it here. 8.1. That's 8.3.1, okay? 8.3.1, 8.3.1, 8.3.1. So here. Now, if you look at our V2 here, we see that our V2 is equal to the V across the 10 ohm resistor plus V1. We together. I'm looking for this V10, okay? So they gave us V2 as 9, okay? So how do you find the V10? Our V10, the same as saying the current I, okay. Anyway, I have here, I'm looking for this V10, so I can leave it like this, V10 ohms, now plus V1, but I have a relation there. They said that, let's check it again in our given information. Don't forget that V2 equals to 3V1. So what about V1? Okay, V2 is 3V1, okay. V2 is 3 what? 3V1. So if V2 equals to 3 V1. What is V1? Divide by 3. Divide by 3. So meaning V1 the same as a third times what? Times V2, okay? But what is our V2, guys? V2 is 9. So I'm going to say V across the 10 ohm resistor plus a third times 9, okay? So 9 divided by 3 gives me 3. 9 minus 3 gives us V10 as 6. So it's going to be 60 volts. That is for the V across the 10 ohm resistor. Let us proceed then here. They say now calculate reading on the ammeter A1. I want reading on ammeter A1. Now that I know the voltages, my ammeter A1 is the same as I1 plus I2, okay? Because I know the V2, I can find the current, okay? I can find what? The current. So I can say V2 equals to I times resistor 2. So V2 they said is 9, okay? I'm looking for this current. In this case, I'm putting it I2, okay? What about resistor 2? We go to what? We got it was 15. Hope you remember 15 ohms, okay? So our current I2 equals to 9 divided by what? Divided by 15. But the current I, we said is double, or is the same as these two branches added together, né? And the branches are equal, so it's gonna be 9 over 15 plus 9 over 15. So which answer do we get here? Calculators. We want to get what? We have there 9 over 15, okay, plus 9 over 15. What do we get? Here we get 1,2 amperes. So we have 1,2 amperes. 1,2 amperes is our reading on ammeter A1. It is 1,2 amperes. Okay. That is question 8.1. 8.3.2. 8.3.2. Okay, next question here. What must we do? They say they want us to find the internal resistance. Okay. Now, internal resistance is what we need. So what do we do here? To get our internal resistance, let's get some space here. Let's get some space here. Internal resistance, what we are looking for. So now we know that from EMF equals to current I into external plus internal resistances. Then here we go. Okay. Here we go. What do we do here? Don't forget that our resistor 1, it was 5, right? This is 5 ohms. This is 15 ohms. Okay. 9. So we know EMF equals to current I into external plus internal resistance. Okay. They gave us EMF. So the current I we know. Let me find the external resistance first by adding all resistors in series plus resistors in parallel. So this is only this 9 here. I'm gonna say that's 9 ohms. Okay. Then in parallel I have got these two in parallel here. What is 5 plus 10? That is 15. So even down, I'm gonna actually use product over sum. I'm gonna say product over sum. That is 15 times 15 divided by what? 15 plus 15. Okay, so here, what do I get as my term resistance? That is 9 plus what? 9 plus 15 times 15 divided by 15 plus 15. What do you get, guys? Then here I get 16,5. So I get 16,5 ohms. So from this formula again, okay, I have my EMF as 20,4 equals to 1,2. That was the current. Okay, open bracket. This is 16,5 plus internal resistance. So divided by what? Divided by 1,2 divided by 1,2. Okay. So what do I get here as my internal resistance? Calculators. The 20,4 divided by 1,2, then minus what? Minus 16,5. So here it gives me 0,5 ohms as my internal resistance. Okay, hope we are together. Let's finish up this paper. I see here that next question here, question 9. They say here that the diagram represents a simple generator. The coil is rotated in anti-clockwise direction. Okay, you can see it here, anti-clockwise. This is output. Okay, they say that does the diagram represent an AC or a DC generator? Now, if you check what we have here, these are slip rings. So because of the slip rings, this is called the AC generator. So we say it is what? We say this is an AC generator. This is what? This is AC generator. AC generator. Okay. Then reason, presence of what? Presence of the slip rings. Presence of slip rings. Okay. Then next here, state energy conversion that takes place in this generator. Now, the generator, it converts from mechanical energy to electrical energy. So we are converting from what? From mechanical energy to what? To electrical energy. To electrical energy. Okay. Let's say for the parts labeled A and B in the diagram, I'll write down. Now A and B, they want their name. So what do you think, guys? Do you remember this? Now A and B, we call them carbon brushes. Those are called what? Those are called carbon brushes. So A and B, we call them what? These are carbon brushes. Now they say after naming them, what do they do? What do they do, these carbon brushes? Now the generator is to produce electricity. So the carbon brushes, they transfer electricity from the induced current from the slip rings to the external circuit. So they do what? They transfer the induced current. They transfer the induced current. Okay, from what? From the slip rings to the external circuit. From slip rings to what? To external circuit. Now, external circuit could be a light bulb, anything. Okay. All right. Next question here. They said that 9,4. They say here 9,4. The part XY of the coil is about to move upwards. As soon as it moves upwards, will the induced current flow from X to Y or from Y to X? So the part XY of the coil is about to move upwards. As soon as it moves upwards, will the induced current flow from X to Y or flow from Y to X? Now let's check it out. Is it X to Y or Y to X? Okay. So now in this particular case, with the generator, we said that we use the right hand rule with the generators. Okay. So if I do my fingers here and I do my north to south, and then that one moves up. Okay, so here I can see with my fingers that because it's rotating anti-clockwise, then the current is going to move from where to where? It's going to move from, okay, so what do you see there? It moves from where to where? Yes, my right hand here, it shows me it is from X to Y. If you did correctly, you're gonna see this flows from where? From X to Y. Okay, so this is X to Y. X to Y here. Now they say that the peak voltage supplied by this generator is what? 120 V. That is our V maximum. You can call it V naught. Okay, is what? It is 120 volts. They said that in the position that the coil is shown, is the output voltage is 0 volts, 85 volts, or 120 volts. Now, in the position that it is shown, Is it 0 volts or 85 or 120? Now the maximum is what? Maximum is 120. Okay, let's check it here. Now the way it is shown here, they said that the diagram represents a symbol generator. The coil is rotated in an anti-clockwise direction. Okay. Now, if you see it here, you can see that in this particular case, it is what? It is vertical. Okay. It is vertical here, and for that matter, our voltage will be what? Will be the minimum. It's gonna be 0 volts. Okay. If it was horizontal, okay, all parallel to the magnetic field, it was gonna be maximum, né? But because it is vertical, we say it is what? It is 0 volts. That's from our theory. Okay, so here it is what? It is 0 volts. Okay, then next they said that the RMS value of the current supplied to the external circuit is 1,2 ampere. That's IRMS. Okay, I root mean square is what? It is 1,2 amperes. What must we do? They said here, define the term root mean square current of what? An alternating current. So hope guys you remember, what did we say about the RMS? We said that the root mean square current, okay, is what? Is the alternating current which dissipates the same amount of energy as an equivalent DC. I repeat, the root mean square current, we said is what? It is the alternating current which dissipates the same amount of energy as an equivalent direct current. Okay, next is here. This is the calculate average power output of the generator. So what do we know about our average power? So P average, you can get it in 3 ways depending on the given information. So here we have the root mean square current. Okay, we can use I root mean square. We can use I root mean square times V root mean square times V root mean square. So because we have the I, that is the 1,2 for the I root mean square. Now to get our VRMS, the question gave us what? The question gave us they gave us here the maximum. They gave us 120, which is V maximum. So we use V maximum divided by root 2. So you can say 120 because V maximum, divided by root 2. So calculators, what do you get here? What do we get here? Calculators, multiply for me there. If you say 1,2 times 120 divided by root 2, here it gives me 101,82. 8234. Okay, it gives me 101,8. Okay, 82, then 34. Okay, now power is measured in watts. Okay, that is it there. Next question, let's check it out. What does it say? Question 10. The diagram below shows a photoelectric cell which is connected to an adjustable EMF. A group of learners use the device to study the photoelectric effect. Okay, so this is what we see here. And then they said the learners irradiate the cell with blue light of wavelength 470 nanometers. They record the readings on the ammeter as the cell is irradiated with blue light of different grades of intensity. They say describe in words what you mean by what? By photoelectric effect. So what did we say is photoelectric effect? Anybody who remembers what is photoelectric effect? So we said that the photoelectric effect, okay, it's a process where electrons are ejected from a metal surface when light of a suitable frequency is incident on that surface. I repeat, photoelectric effect is the process, okay, where electrons are ejected from a metal surface when light of a suitable frequency is incident on that surface. Okay, then they say for this experiment, write down the following: the independent variable. Now, what is independent variable? We said that if it is going to be independent, that's what the experimenter is changing. So in this particular case, these learners, what are they changing? The different grades of intensity. So our answer is going to be intensity here. Okay, so the intensity of light is our independent variable. So our IV, call it independent variable, it's going to be what? It's going to be the intensity of light. Okay, that's what they're changing. They're using different grades of light. Okay, light intensity. Okay, next question here. They said that write down one factor that must be kept constant. So what should be kept constant in this case? What must be kept constant in this case? So in this case, for us to have a fair investigation, okay, we must have the same what? That's what must be kept constant here. We should have the same wavelength or the same frequency. So we should have light of the same wavelength or light of the same frequency. Okay, you can say you should have light of the same frequency. You should have light of the same frequency. Light of what? Of the same frequency. Okay, light of the same frequency. And then next year they say write down an investigative question. Now guys, what is investigative question? What do we know about investigative question? We know that it is that question which is asking the relationship between the independent variable and the what? And the controlled variable. So for this matter, what can we say? We talked about the intensity of light. All together, we talked about the frequency. So what can we say in this case? If you want, you can say how does, or how will, or what is the influence. Okay, so you can say it in any way. So for example, you can say here that what is the influence of the intensity of blue light on the current strength of a cell? You can say what is what? What is the influence, okay, on the intensity of blue light on the what? On the current strength of the cell. You can say what is what? You can say that what is the influence, see, all together, of the intensity of blue light on the current strength. Okay. Next question here, they say that the learner observes that the ammeter readings increase when the intensity of the blue light increases. Explain this observation. Okay, so what do you think? You said that what do they observe? That the ammeter readings increase, okay? That ammeter readings increase when what? When the intensity of blue light also increases. So they say we should explain this. So what can you say? What can we say? Now here, the greater intensity, it means that we have more photons which are irradiating the metal surface per unit time. Okay, we have more what? We have more photons which are irradiating the metal surface per unit time. That's why they are proportional. So the greater the blue light intensity, the greater the ammeter readings. So here we say that because of what? Because of more photons that irradiating the metal surface per time. Because of more what? Because of more photons, okay? Because of more photons, because of more photons that irradiate, okay? That irradiate the metal surface per time, okay? Irradiate what? The metal surface per unit time, per unit time, okay? And so what happens? You know, these are directly proportional, né? So when we have got more photons irradiating the metal surface, then we're going to form what? We're going to form more photoelectrons. altogether, and hence a higher metal readings. So this results in what? Resulting in more photoelectrons leaving the what? The metal surface, and hence a higher metal reading. So here, the first point, we have more photons irradiating the what? The metal surface, resulting in more photoelectrons leaving the surface, and hence what? A higher metal reading. Okay, hope we are together. Then they say here that the metal of the photoelectric cell has a work function of 2,35 x negative 19 joules. Calculate the maximum kinetic energy with which the photons are emitted from the metal. Okay, so what do we do in this case? They gave us what? The work function W naught. Okay, that's our W naught, which is the work function. Okay, so we know this is the work function, which is our W naught. Okay, and we need maximum EK. Okay, we need EK maximum. Okay, we need EK maximum. Okay, all right, so what do we do to do our calculation here? What do we use in that case? Now from our equation, we know that our E, okay, remember the incoming photons have got energy. Ne? That energy E, okay, is divided into two. The first energy is it's taken as work function altogether, and then the remaining energy is responsible for the what? For the maximum kinetic energy of these photoelectrons. So now we know that in this case what we have, let's check it properly again. Check properly our question one more time. What do we have in this case? They say that the lens is relatively concerned with light of this wavelength. Yeah, this is for 70 nanometers. So we have the wavelength of the incoming light. Okay, so we are going to use it to find our energy E. Are we together? To find our what? Our energy E, and then later we can find our work function as well, so we can find our EK maximum. Anything else which we know here? Let's check here. That the learners irradiate the cell with the blue light of this wavelength here. They record the readings on the ammeter as the cell is irradiated. Okay, so this is the wavelength of the incoming light, the 470 nanometers. Okay, 470 nanometers. So what do we do in that case? Yeah, we said we have the incoming radiation with this wavelength here. Okay, now check this formula again. We said 470. So because we have wavelength, now the formula must change. We are going to say that our HC, okay, HC divided by lambda, okay, equals the work function plus our EK maximum, which we're looking for. Now in this case, I'm going to say that my EK maximum, okay, EK maximum equals to HC divided by lambda, okay, minus what? Minus work function. Now this H is called Planck's constant, given by which value? 6,63 times 10 power negative what? Times 10 to the power negative 34, okay? And then the C is what? Is 3 times 10 power 8, okay? So times 3 times 10 to the power 8, now divided by what? Divided by lambda. That they gave us 470, no? Okay. So, but they said nanometer, so we're going to say 470 times 10 to the power negative 9, okay? Then now minus what? Minus the given work function. Hope you still remember that. It is just on here the 2,35 times 10 power negative 19. So we're going to say here minus 2,35 minus 2,35, okay, times 10 the power negative 19. So what do we get finally? Now here on my calculator, I get 1,882 times 10 to the power negative 19 joules. 1,882 times 10 power negative 19 joules. Okay. Alright guys, we can stop here. Thank you so much for watching. My name is Kamala. I'm a tutor and educator for mathematics and physical sciences, Coastal College Pulukwani. You can reach me on 0785 222 041 if you want to really get better marks and you want me to tutor you in person. Bye bye.